trace of element of n. That is your fundamental matrix. And this relation you have obtained by using the equations, and that equation is basically, if you differential equation is given as in this form. If this form, okay, so the matrix representation of this is equals to, you can write in this way. Okay, and if be the fundamental and be the fundamental matrix, then this satisfies your equation, that is the matrix equation. Okay, so yesterday we I think this is equation number one, and this is equation number two, and this is equation number three. Okay, so today there are some remark on the fundamental matrix, that is a solution matrix of, if we write this solution matrix, this is equation number three. So the solution matrix of equation 3 on the given interval I is fundamental matrix. This is a fundamental matrix of equation first on the given interval if and only if you the determinant of that fundamental matrix is not similar, or this is a non-zero. Okay, so if and only if this determinant of this fundamental matrix is non-similar for x is belongs to that given interval R. Okay, so proof of this remark is very simple. If we consider or assume that this fundamental matrix M be non-singular one, okay, so then this determinant M is not equals to 0 for all x which belongs to that given interval I. So then if the determinant is non-zero, then the columns of that matrix, that is M, is linearly independent. And if the columns are linearly independent and they are the solution of that, this means this is your fundamental matrix. Okay, so if we assume that M be solution matrix, and this is says that the determinant of this mx is non-zero when x belongs to full interval I. So then the columns of the fundamental matrix are linearly independent. Okay, on just give it interval I. So if any matrix which is a solution matrix and their column are linearly independent, then that matrix is said to be fundamental matrix. So hence your M is a fundamental matrix. Okay. Similarly, there is another remark, that is said that suppose M be fundamental matrix, okay, for the given system, and that system is called 1, and let C be any constant non-singular matrix, and also we assume that this C be a constant non-singular matrix. So this says that the product of these two matrices, then this M into C, this this is also this is also fundamental matrix, for the given system, that is equation 1. Okay, or you can say that in addition to that, you say every fundamental matrix of equation 1 is, this is MC for some non-singular matrix C. Okay, this means you have to prove that if M be the fundamental matrix and C be any constant non-singular matrix, then you have to prove that this M into C is also a fundamental matrix. Okay, so this means this proof is in 3 to 4 lines only. So here
हेलो
this
सर।
uh-huh,
सर ये एवरी
बोलो.
फंडामेंटल मैट्रिक्स ऑफ के बाद ये क्या लिखा हुआ है?
Yeah, this is question number 1. This is question number 1. This system. This system 1. Okay.
ओके
Of
सर।
equation 1. Okay. So since M is basically this is given, so हम ये लेके चलें कि M is fundamental matrix. Okay. And if M be the fundamental matrix, then here if M be the fundamental matrix, the determinant of M is not equal to 0. This means this fundamental matrix is always non-singular. So then M is non-singular. Okay. So if M is a fundamental matrix, therefore M हमारी non-singular होगी. और यहाँ क्या है दिया है? This is also given that C जो है आपकी एक non-singular matrix है. तो M भी आपकी non-singular, C भी non-singular. So product of two non-singular matrices is also non-singular. Okay. So the product of two non-singular matrices is non-singular. So therefore this M into C is non-singular. Okay, so now if we suppose that let say two fundamental matrices, so let M1 and M2 be two fundamental matrices, this equation first. So if these two are fundamental matrices, so M1 is non-singular and M2 is of course non-singular. So then their inverse is exist. So you can multiply with so M1 is non-singular. So this means M1 inverse is exist. And say if you multiply it by M2 and say this is equals to be the product of these two matrices, so this becomes N. Okay, so here we assume that if we let this M2, this equals to suppose M1N. Okay, so this M2 is M1. Okay, so if you multiply by M1 to both sides, this becomes M2 and here M1N. So if we assume that this M2 equals to M1N, then this M2 prime equals to the first matrix differentiation of second plus differentiation of first then second. So from equation 3 from equation 3 from equation 3 uh, implies that here what is M2 prime, because satisfies your matrix. Oh, this is M, because this satisfies matrix equation M prime equals to AM. Okay, so here M2 prime equals to A M2 from equation number uh, this is so equation number 3 and this is equation number 2. Okay, so equation number 2. From equation number 2 you write this AM2 uh, this M2 prime that equals to M2 prime that equals to AM2, and this implies if we look here, so this becomes AM2, this equals to this is M1 n prime plus M1 prime n. Okay, so here you can also write what is the value of M1 prime. So M1 prime is of course from equation 2 you can write this M1 prime. So M1 prime is AM. So you can write A okay. So M2n M2n prime plus M2n prime plus what is the value of M1 prime? So M1 prime is AM1n. Okay, so this equals to okay. So this implies this is M1n prime, this first term, then plus A, and here this term is A M1n. And what is the value of M1n? M1n is M2. So this becomes A M2. So this is AM2. Okay, so this implies you finally, what is the value of AM2? So you AM2 equals to this M1 N1 prime plus AM2. Okay, so here these two are same. These two are same. So this implies M1 N1 prime that equals to 0 because these two are same. Okay, so here this M1 N1 prime is 0, and this means product of these two matrices is null matrix, and here M1 is non-singular. M1 is non-singular. This implies N prime is singular one. Okay, so this implies you get this N prime is null matrix. So N is your constant matrix. Okay, so here therefore N equals to C. So N equals to C means you find here what is your assumption. So you take here this M2 is this N equals to the constant matrix. So therefore you your solution is M1C. Okay, so if we're putting N equals to C, so then you get this M2 be the M1C. This means if M1 be the fundamental matrix and C be the constant matrix, then the product of these two is also your fundamental matrix. Okay, so if M1 any fundamental matrix, if we multiply it by any arbitrary constant, so that matrix is new matrix is also the fundamental matrix of your given system. Okay, so this is your proof. Okay, which depends on your fundamental matrix. Okay, so now
Implies that उसके बाद से सब नहीं समझ में आ रहा है.
ये लाइन क्लियर है, ये यहाँ से बताऊं?
Yes sir, यहीं से.
हाँ, ये M2 prime, if M1 and M2 are fundamental matrix, then here from here you have this M1 and M2 का fundamental matrix है, तो M1 prime हमारा AM होगा 1 and M2 prime जो होगा that is AM2 होगा. क्लियर? ये चीज हमारी होगी if M1 and M2 are fundamental matrix. ठीक, तो हमने लिखा यहाँ से कि M2 prime is AM2 and what is the M2 prime value क्या है हमारे पास जो value है तो AM2 equals to M1 n prime plus M1 prime n. Okay, and here M2 n prime and this value M1 prime is AM1. तो यहाँ पे होगा आपका, यहाँ पे आपने लिखा M2 n prime तो लिखा ही, और इसकी जगह क्या लिखेंगे आप, किसकी वैल्यू आप फाइंड कर रहे हो, M1 prime n. ये क्या होगा, तो M1 prime की वैल्यू क्या है, that is AM1 n. Okay, and here from this equation here you let this, what is the value of M1 n, so this is A and this value is M2. So here we write M1 n prime first term is this, and plus this value is AM2. So we can write here AM2. So left hand side is AM2. So AM2 equals to M1 n prime plus AM2. Okay, so here both matrices are same. That's why you get M1 n prime that equals to 0. And here M1 is non-singular matrix and N1 prime the product of these two matrices equals to 0, and one is non-singular, therefore another one is singular one. So this implies n prime equals to 0. So therefore if n prime is derivative of that is 0, so n is your constant. So if you're putting here n equals to c in our this main assumption, so we get here this fundamental matrix n2 that equals to m1 into c because n equals to c. Okay, so here we can say easily if M1 be the fundamental matrix, then another M2 be also a fundamental matrix, but this equals to this multiplied by any arbitrary constant C matrix. Okay, so अगर आपकी कोई भी आपके पास fundamental matrix है, उसमें आप कोई भी non singular matrix से आप multiply कर लें, तो वो जो form होगी, जो नई matrix होगी, वो भी आपकी fundamental matrix होगी same system. Okay, तो यही चीज है ये. Clear?
Yes sir.
Okay. So in next page, we go to non-homogeneous linear system. Okay. Okay. So okay. So next heading is non-homogeneous linear system. Okay. So suppose if AX be any non n cross n matrix of this non-homogeneous system that is continuous on some interval, and also suppose this B be also matrix which is column vector, this is from Rn, and this be continuous function on same domain. Okay, so the system, and this system is, if we write this form where x belongs to I, and this system is known as non-homogeneous linear system of n equations. Okay, this is the system is called a non-homogeneous linear system of n equations. And here this term B, what is your term B? This term B is known as, this term is known as a your forcing term or perturbation term. Okay, so this non-homogeneous term, this is also known as a forcing term or perturbation. Okay, so if we recall the continuity of A and B, this because A and B are continuous, so there exists
Forcing term or
perturbation, Perturbation, perturbation. Okay, so this is perturbation, you know, and in nonlinear dynamics, if we go in the higher studies in research, so this perturbation term is very useful for doing research. Okay, और कैसे हम थोड़ा सा अपने सिस्टम को पर्टर्ब कर दें थोड़ा सा, और फिर उसके बाद उसमें क्या इफेक्ट आते हैं, तो ये सारी चीजें आप हायर स्टडीज में जाएंगे तो यहाँ पे उसका वो सारी चीजें एप्लीकेबल मैथमेटिक्स में आती हैं. ओके, एंड हियर पीजी कोर्स ओनली यू नो दैट व्हाट इज हाउ टू सॉल्व दिस सिस्टम. ओके, सो ओके, तो यहाँ पे हम ये लिखें कि due to this A and B are continuous in this domain I, so there exists existence and uniqueness of that initial value problem. Okay, so here we recall that the continuity of A and B, this ensures the existence and uniqueness of solution of given initial value problem. So we can write this on given interval for the system. If we take our system first, okay, so system A, okay, so to express solution this A in terms of system 1, we resort to the method of variation of parameter. Okay, so here basically here we let this M be a fundamental matrix for the system 1 on interval I, and suppose your N be a solution, basically is a unique solution. So this N be a solution of your system A, okay, such that for any point which belongs to that interval and this initial condition are satisfied. Okay, so if we assume that any u which is a differentiable function and the initial condition satisfies, so now let us take your Mx, which is the general solution of this equation system of A. This equals to Mx. So here you can write next line. So this is, we assume that this Nx, which is the general solution of the system A, and this is Mx, which is the from homogeneous system of equation. That's why we consider this from system M. So M be the fundamental of that homogeneous system. So this into Ux as similar in the method of variation of parameter. Okay, and here this U. Okay, and suppose X is belonging to that interval where you have to find what is the value of U. If you are able to find that value Ux, if you find out this Ux, and if you multiply it by that homogeneous solution, that is fundamental matrix Mx, then product of these two is your general solution of this non-homogeneous system of linear equation. Okay, so here you have to find what is the value of U. So U is basically unknown. Okay, and here we are trying to find how to what is the value of that Ux. So this to be determined, you have to find that value. Okay. Okay, and say this is equation number, suppose B. Okay, so this is your general solution of this equation A, and B is the general solution. So we have to find what is the general solution of this non-homogeneous system of equation. Okay, So here in next page, uh, we take this relation and proceed. So in next page, we have this nx equals to, from last page, uh, you have this relation. Okay, so and you said this is equation number b. So from this, from equation b, you can write this n prime that equals to m prime ux plus mx u prime x, if you differentiate both sides of this equation number b. And here you know that this m prime and this m be the fundamental matrix of your homogeneous system. And what is your homogeneous systems? Homogeneous system is your this y equals to this ax of y prime, and this satisfies your fundamental matrix. You know that this relation you are already you have used in previous theorem. What is the value of m prime? So this m be the fundamental matrix of your homogeneous system. So that's why m prime satisfies am. So this equals to, this is ax mx, and here ux, and plus this mx u prime x, and say this is equation number c. And this relation holds due to this m prime equals to am. Okay, so that's why you write this thing. This is equation number c. Okay, or you can write this is equation number star. Okay, because there is no need. So because this is if we marking this star. Okay, so since our nx be the general solution, or the solution of our equation of system of non-homogeneous equation, that is A. So then if this is the solution of your non-homogeneous system, and what is your non-homogeneous system? Our non-homogeneous system is ay plus something b. Okay, so if this is the solution of that, then this satisfies this relation. So we can write here n prime this equals to ax nx plus bx, because this nx be the general solution of this system A. Okay, so that's why this nx satisfies this relation. So if we suppose we can write here what is the ax and n. So here we can write ax, and what is n? N is your mx and ux. So here you can write mx ux plus bx, because this nx equals to mx ux. So this is your equation double star, and of course here x belongs to that interval and x belongs to that same interval I. Okay, so now here from equation star you see that this nx prime is this thing, and here this nx prime is this thing. So left hand side are same, so right hand side, if equating this, so first term is ax mx ux, so here amx mx ux plus bx. So here if you comparing these two, you get from equations star and double star, we get this simply bx is equals to mx u prime x for all x that belongs to same interval. Okay, since you know that since mx for the given interval, this is your fundamental matrix, and every fundamental matrix is non-singular. Okay, so that's why we have, if this is non-singular, so this possesses inverse of that. Okay, so this means m inverse exists. So therefore you can write here this u prime x, this equals to m inverse fundamental matrix inverse of that Bx. Okay, so if you are trying to find this ordinary solution, and if we put here the तो ओके तो आप इस प्रॉब्लम को आप हम नॉर्मली हम ऑर्डनरी जैसे हम सॉल्यूशन करते हैं उस तरह से हम सॉल्व कर लें, या फिर आप चाहें तो इसमें इनिशियल वैल्यू प्रॉब्लम भी आप यूज करके सॉल्यूशन निकाल सकते हो। तो दोनों दोनों ही हम कर देते हैं, दोनों ही करते हैं। ओके, तो ओके, सो हियर कैन राइट for indefinite integral, so that's why this if we integrate this over dx, अभी हम initial value problem use नहीं कर रहे हैं, तो simply if you integrate this, so this equals to integral of m prime, and this is m inverse x, and this is bx and dx if integrating to both sides. So here you can find what is the value of ux. So ux is equals to that is integral of that. So here this is u prime because this thing. Okay, so integral of this is simply ux. This is simply ux. Okay, this is ux. Ux equals to integral of that. So integral of that, this means you add arbitrary constant and integral and inverse px dx. Okay, so this is your integral. Okay, so if you substituting this value of your what is your ux, so what is the solution of nx, so what is the general solution? तो अगर हम इसको इक्वेशन नंबर c कहें तो from b and c, so from equations b and c we get what is the general solution. So general solution is this equals to, if we multiply by this mx, this c mx plus mx integral m inverse x bx dx. Okay, so this is your general solution, and here this is the general solution, and this corresponds for your complementary solution. Okay, this is from your homogeneous term because m is obtained from the homogeneous system of equation. So this is complementary solution. Okay, this is complementary solution, and this is your particular solution. This is your particular solution. तो स्पेस नहीं है, छोटा ही लिख रहे हैं, समझ जाइए. This is particular solution, and this is complementary solution, and this is the general solution. Okay, so here we find here this is the without using initial condition. But here if you use initial condition, so if you use initial condition, then this integral we take here initial condition. So you can write here for x and x naught that belong to that interval. So that's why we find from this stage, so you can integrate your initially x naught to x of u prime x. This equals to integral x naught to x, and here m inverse, and here we change the variable because the limits are in terms of x. So here we change this is in terms of this integral. Okay, so we change this variable. Okay, and now you can solve this. So here you obtain u prime x minus u prime x naught is equals to integral x naught to x m prime x and ds if there is an initial value problem. So if initial value problem, then from this you go through this step, and if there is no initial value problem, then you go to that step. Okay, so here
सर
हाँ
सर ये
ux
ux
is
x
minus
होगा.
ux naught होगा.
ओके
टाइम लिखा हुआ है।
हाँ 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 ओके थैंक यू। थोड़ा सा जल्दबाजी में हम गड़बड़ी हो जा रही है। अब ठीक है ओके ठीक है।
Yes, sir.
वैसे वैसे जहाँ जहाँ भी कहीं प्लस माइनस हो ऐसी चीजें हो तो बिल्कुल आप हमें इन्फॉर्म करें, हमसे तुरंत करेक्ट करेंगे। ओके सो दिस इंटीग्रल ऑफ दैट इज यू एक्स एंड यू एक्स नॉट। ओके ठीक ठीक। And now we using what is the initial condition here? Okay, so what is the initial condition? So from equation B, equation B, you have x of x0. This equals to m x0 ux0, and here in what is the value of nx0? So nx0 is 0 already given in starting, and here mx0 and u0. Okay, and since m is the fundamental matrix, so this is a non-zero, and product of these two is 0. So that's why this ux0 is 0. Okay, so now you're putting here what is the value of this is 0. So here ux equals to simple integration of that term. Okay, so here what is ux equals to integral x naught to x m prime s bs ds. So this is the solution. Okay, this is ux. Okay, so what is the solution is, so here what is the solution is nx. So if you multiply it by that, so what is nx? So nx is mx integral x naught to x m inverse s bs ds. Okay, so this is the general solution of initial value problem. Okay, तो आप यहाँ इस solution और इस solution में अगर आप दोनों को देखें तो आप ये कहोगे कि अब भाई इसमें तो एक टर्म एडिशनल आ रहा है, यहाँ तो mx और यही चीज है। ओके बट यहाँ पे अगर आप थोड़ा सा ध्यान दो तो यहाँ है क्या बेसिकली, ये आप इसको इंटीग्रेट कर रहे हो, डेफिनेट इंटीग्रल है। दिस मीन्स you have putting this value as x here, this means you got this term, and when we putting x naught here, so this becomes at x equals to x naught, this become a constant one. Okay, because x naught is a finite number, so when you integrate this and putting s equals to x naught, the finite number, this value is a constant one, and constant one multiplied by that mx. So you got this constant multiplied by that mx. This is complementary portion. Okay, so ये और ये दोनों ही सेम है, दोनों ही फॉर्म सेम है। ओके, बस यहाँ पे देखने पे ये लगता है कभी कभी कि इसमें तो हमारा mx और इंटीग्रल ये टर्म है, बट यहाँ एडिशनल टर्म यहाँ पे मिसिंग है, लेकिन नहीं, वो टर्म हमारे जब आप इंटीग्रेट करोगे तो उसके साथ आ जाएंगे। Okay, so this is basically the derivation and what is the formula of that. तो हम एक छोटा न्यूमेरिकल क्विकली कर लें, बिकॉज हमारे पास 30 to 40 मिनट्स हैं, तो हम जल्दी से एक इसमें न्यूमेरिकल कर लें। और तो next page, on next page we find the general solution for non-homogeneous system of equation by using this formula. Okay, so in next page so system is Px, where this A is, we take 2 cross 2 matrix, and what is Bx is suppose so 6 e to the power 2x and minus e to the power 2x. Okay, so this is a system of non-homogeneous integration. Okay, so here we solve quickly, and you have to you know that how to find the fundamental matrix first. Okay, so when we find fundamental matrix, you have to obtain A minus lambda I that equals to 0. So this implies this is 4, this is minus 2 minus lambda that equals to 0. This implies, okay, so we solve this quickly, and if anywhere some mistakes, so you can inform me. And this is plus 6 and this is plus 1 that equals to 0. So lambda equals to minus 1 and lambda equals to minus 6. Okay, so there are two eigenvalues. So for lambda equals to minus 1, so your this matrix is this plus 1 and this is 1, this is 4, and here this is minus 1. And if eigenvectors are v1 and v2, that equals to 0 0. So here you can find this plus v2 that equals to 0, and second equation is 4v1 minus v2 0. So this implies v2 equals to 4v1. So if we have v1 is something a, so v2 is 4a. Okay, 4a. So that's why your vector is for lambda equals to minus 1, lambda equals to minus 1, our first vector that equals to you can write 1 4 transpose because this is 1 and 4. Okay, similarly for lambda equals to minus 6, so your matrix is plus 6 1, this is 4, this is, and here eigenvector that equals to 0 0. So this implies your v1 v2 0, and from second this v1, okay, this v1 plus 4 v2 0. So this implies v1 is minus v2. So if v2 is a, v1 is minus a, so your vector is 1 minus 1 transpose. Okay, so what is the fundamental matrix in this case? So the fundamental matrix, here you can write mx. This is equals to, what is your eigenvectors are 1 and 4, and second one is 1 and minus 1. Exponential of what is the eigenvalue is minus 1, so this is minus 1. Okay, this is minus 1, and here this is minus 6, so this becomes minus 6. So you can write easily fundamental matrix. So what is your fundamental matrix is e to the power minus x, and 4 e to the power minus x, this is minus e to the power. Okay, so our eigenvector, okay, v1 is minus 1 plus 1, minus 1 plus 1. So here this is minus 1 plus 1. So here this is, okay, minus 1 and e to the power this thing. So this is your fundamental matrix. This is your n. Okay, so you have to find what is the determinant of m. So determinant of m is if we multiply this thing, this equals to minus 7x plus 4 e to the power minus 7x. This equals to 5 e to the power minus 7x. So you have to find m inverse. Okay, so what is the m inverse? And okay, so why we find m inverse? Because our particular solution is, what is our particular solution? Particular solution is you know that this matrix mx integral, this is m inverse. That's why we find the inverse of that, and this multiplied by dx, dx, and dx. This is your particular solution, because here no initial conditions are given. Okay, so that's why we find this is the particular solution. And what is your homogeneous solution? So homogeneous solution is your C into mx, and the general solution is, if you add in these two, this is your general solution, that is nx. Okay, so that's why we here we find what is the m inverse. So first of all, we find the fundamental matrix, then inverse of that, then multiplied by that dx, and then integrate that, and then multiplied by that mx. Okay, so in next page we try to find what is the inverse of that. So next page, okay, so what is m inverse? So m inverse is 1 upon mod of m, this is e to the power minus 7x, and then cofactor transpose, so this becomes minus 4 this, and e to the power minus x, and here e to the power minus x, and transpose of that. So our inverse is 1 by 5 e to the power x minus 4 by 5 e to the power 6x, and here 1 by 5 e to the power x, and here 1 by 5 to the power 6x. So this is your inverse. So now you have to find what is m inverse with bx. So this equals to e to the power x over 5, e to the power x over 5, here minus 4 e to the power 6x over 5, e to the power 6x over 5, multiplied by b, and b is 6 e to the power 2x, and minus e to the power 2x. So if you multiply that, it just becomes 6 by 5 minus 1 by 5, 6 by 5 minus 1 by 5 e to the power 3x, and here minus 24 by 5 minus 1 by 5 e to the power 8x. Okay, so here we get e to the power 3x and minus 5 e to the power 8x. So this is the multiply of that. Okay, so then the particular solution, then particular solution, that is you write yp, this equals to mx integral m inverse x bx dx. So this equals to, this mx is e to the power minus x minus e to the power minus 6x, and here 4 e to the power minus x e to the power minus x multiplied by this thing. If you integrate this thing, so this becomes the power. Okay, so now we write here integrate this integral e to the power 3x minus 8x. Okay, this dx. So this equals to, if you integrate this thing, so this becomes e to the power 3x by 3, and here minus 5 by 8 e to the power x. Okay, so you multiply that, so this implies yp equals to e to the power minus x, 4 e to the power minus x, and here minus 6x e to the power minus 6x multiplied by, and this is e to the power 3x by 3, and here minus 5 by 8 e to the power 8x. So if we multiply that, so you get this becomes 1 by 3 plus 5 by 8, so this becomes 23 by 24 e to the power 2x, and here this is 4 by 3 minus 5 by 8, so this becomes 17 by 24 e to the power 2x. Okay, so you can find this thing. So here this implies what is your particular integral e to the power 2x. If you taken outside, this becomes 23 by 24, and here is 17 by this thing. This is your particular solution. Okay, so what is the general solution? So what is the general solution? So here we write then the general solution that is yx, that's equals to y homogeneous solution plus particular solution. This is for complementary solution, and this is for particular solution. तो complementary solution क्या है? Complementary solution आपको मालूम है C1 e to the power lambda 1, this is this thing, and eigenvector are 1 4. Okay, plus C2 e to the power, this is second eigenvalue is 6x, and eigenvectors are, this is minus 1 1. This is your complementary solution. And plus, what is the particular solution? Particular solution is e to the power 2x 23/24, 17/24. So this is your final solution. Okay, so you can find out by this method what is the general solution of any non-homogeneous differential equation. Okay, तो आज इतना ही करते हैं, ठीक है। तो नेक्स्ट हम कल हम और दूसरी चीज लेके बताएंगे आपको। तो मेरे ख्याल से प्रॉब्लम आपको क्लियर होगी, ठीक है। तो आज के लिए इतना ही करते हैं, अब आगे नेक्स्ट टर्न।
थैंक यू सर।
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.